Welcome to the first part of uh, MET E381 lecture. So the first part would cover the introduction to electro-pneumatic system, and later on we'll try to explore the fluid sim software. We'll be using the said software to simulate electro-pneumatic system. So the term electro-pneumatics is actually a combination of electrical and mechanical system. So there are two systems involved, the electrical system, and then you have there the mechanical system. So for the electrical system, the electric circuit is being used to energize uh, some of the elements in the electropneumatic setup, wherein once these elements will be energized, it will allow the flow of air, which hereby dictates the mechanical movement of the pneumatic cylinders. So the input in an electro-pneumatic system is basically coming from electrical side, and then the output of the electro-pneumatic system is actually the mechanical movements done by the pneumatic cylinders, wherein these mechanical movements in an electro-pneumatic circuitry is being commanded by air pressure. So when you hear the word pneumatic, so it basically means air pressure or air. And then the term hydraulics is synonymous to pneumatics, except that hydraulics uses fluids or basically liquids such as oil to create movement for cylinders. For pneumatics, we're using air as a means for the pneumatic cylinders to move. So the movement mentioned here is actually the extension and retraction of uh, pneumatic cylinders. So the pneumatic cylinders mentioned here can either move in extended position, or a pneumatic cylinder will be in retracted position. So for electro-pneumatic setup, there are actually two components. Okay, so the first component is the pneumatic circuit, and then the second component is termed as the control circuit. So in the pneumatic circuit, so you have there the pneumatic cylinder. Okay, so and then you have there the directional valve, or basically the solenoid valve, and then, well, of course, the source of compressed air. So basically, in a pneumatic circuit, so there are basically three components inside the circuit. So the first part, or the first component, is the pneumatic cylinder. So the pneumatic cylinder may differ depending on its application. So later on, we'll try to explore what are the different types of pneumatic cylinders, and then what are also the corresponding directional valves to be used, no, for a particular pneumatic cylinder. and then you have there the compressed air. So for the control circuit, so if you try to look at in the pneumatic circuit, that is where the mechanical system uh, can be found. And then in the control circuit, this is wherein you can find the electrical system. Okay, so the control circuit may vary. So depending on the movement or the design movement of the pneumatic cylinders, then the control circuit components may also vary. So there is no definite components under the control circuit as to this will depend on the designed movement of the pneumatic cylinders. So unlike in the pneumatic circuit that the distinct components are the pneumatic cylinders, the directional valve, and then the compressed air only in the control circuitry. So even if you have the three components for the pneumatic circuitry, the control circuit may vary. So depending on the type of movement that you want to perform for the pneumatic cylinder. For example, you want the cylinder to, uh, or you want a very simple movement of the cylinder, wherein if you want, or you want the cylinder to extend and then retract. So you have there corresponding control circuit, and if, or when you have, or when you want the cylinder to extend and then retract and then do it or do the same sequence 5 times, then that would be different control circuitry. So but then you will have the same pneumatic circuit elements, but then because you have their different movements of pneumatic or different movements for the pneumatic cylinder, then the components in the control circuit uh, will vary. So this would be the typical signal flow under electro-pneumatic circuitry. So in the first part would be the input. Okay, so the input elements are basically the inputting of the signals. So uh, the inputting of the signals can be or are given uh, by the what we so called input elements, and then these input elements are basically what we call as switches. So after the signal is being input, uh, by the way, input signal is basically a command. So for example, you want the setup to start, then you press, for example, a switch, just like with a lamp that can be found in your home. So you want the lamp to turn on, then you press the switch, and then the lamp will turn on. Okay, so the input elements in an electro-pneumatic system are basically switches. So examples of which will be discussed uh, in a while. So after these input elements, so the next step would be the signal processing. So in the signal processing, it is where the inputs will be processed. So in the signal processing part, the processing elements consist of relays. So generally, uh, the processing elements will be the relays. So what will happen is that For example, when a push button or switch is being pressed, then a relay may activate or may energized or de-energized. Okay, so the uh, functions, the components, and then the uh, what you call the operation of relays will be discussed uh, in the next slides. And then uh, after the signal processing, so the next step would be the signal output. So the signal output, so basically is the command coming from the processing elements, wherein the in the signal output, it is where the directional valves are being controlled. So the elements under the signal output section is basically the solenoid valves or the directional valves. So once these directional valves will be activated or deactivated, so this will allow the flow of air going to the final command execution, which is the pneumatic cylinder. Okay, so in the processing element section or the signal processing section, so it is where the relays are being given with a signal, and then in the signal output, it is where the solenoid valves or the directional valves uh, will be given a signal to either turn on or off, and then once the directional valves will be turned on, so it will allow the passage of air from the compressor or compressed air source going to the final elements, which is the pneumatic cylinders. So, or in the signal output section, uh, when the directional valves will be turned off. So when they are turned off, so they may uh, stop the passage of air flowing from the compressed air source to the pneumatic cylinders. Okay, so if you try to look at, so the signal input, the signal processing, and part of, okay, so part of the signal output section are or can be found under the electrical control section, and part of the signal output section going to the command execution section can be found under the pneumatic power section. So remember, there are two components in an electro-pneumatic system. So the first component is the pneumatic circuit, and then the second component is the electrical control circuit. Okay, so and then you notice that in the uh, signal output section, or basically the directional valves, so it is being composed or divided into two components: the pneumatic a component can be found in the pneumatic section, and a component in the directional valve can be also found in the electrical control section. So it can be further visualized from the next or from the given setup. So in this setup, so you can see here the pneumatic circuit, and then you also have there the control circuit. Okay, so now this is the directional valve that was mentioned in the signal output section. Okay, in this section. So if you try to look at, so in the directional valve, so the directional valve can be found in the pneumatic circuit. At the same time, part of the directional valve can be also found in the control or electrical control circuit. So the pneumatic directional valve, so this directional valve physically is located in the pneumatic circuit, but one part of the directional valve is actually present in the control circuit. So that is actually, if you try to look at, so there is a label Y1 here and Y2 here. So this Y1 and Y2, okay, so can be found in the electrical control circuit. Okay, so Y1 and Y2, so basically are the supply or basically the coils of the directional valve. So the function and then the operation and the parts of the directional valve or solenoid valves will be discussed in the next few slides. So as mentioned from the uh, flow in an electropneumatic circuitry or electropneumatic system is that uh, there will be this what we so called signal input. So the signal input, so in the first part, so the signal input are given by the input elements, so which are given by the what we so called switches. So the push buttons, the limit switches, the read switches, and the proximity sensors are all basically types of switches. So what are switches? So switches are electrical component which can create or break contact in an electrical circuit. So uh, these are basically components which can make, okay, so make means they can create contact or break, uh, they can interrupt also the flow of electrical current in an electrical circuitry. So basically switches uh, will come in the form of open or on and off or close mechanism. Okay, so uh, for a given switch, there are only two types of configuration. So it's either a switch is on or basically open, or a switch is off or basically closed. So there are three types of switches so that can be used in the design of electropneumatic circuitry. So they are given by the following. The first one is the normally open contact switch. So secondly, so the normally closed contact switch. And then the third one, the changeover contact switch. So take note, uh, a switch can be triggered either manually or automatically. So when you say manually, so there must be a mechanism or mechanical mechanism that will turn on or off the switch. So just like the switch that can be found in our home, so when we press the switch, it will either turn on or off. But then there are also switches that are automatically operated. So later on, we'll try to explore what are these types of switches that can be operated automatically. So automatically means there will be no mechanical force, or there will be no mechanical mechanism that will be used to turn on or off a given switch. So the first type of switch is the normally open switches. So in this diagram, or in this uh, given figure, a normally open switch, once triggered, will become closed. Okay, so and then uh, the second type is the normally closed switches. So initially, so there is a contact between this point and this point. Once this is triggered, either mechanically or manually or automatically, then this normally closed switches or switch will become open. Okay, so going back to the normally open, so this type of switch, it's initially uh, does not have a contact from this point to this point. So basically it is open. So once this is triggered, so either manually or automatically, then a normally open switch will become closed. So for the closed or normally closed switches, so once it is triggered, it becomes open. So the third type, okay, so the third type of switch is the changeover contact switches. So it is basically a combination of normally open and normally closed switch. So it is termed changeover because once it is triggered, for example, if you consider this point and this point, so initially the switch provides normally closed contact, but once triggered, okay, so once triggered, this point going to this point becomes normally open, okay, or becomes open, and then this point here and this point becomes or will provide a close contact. So unlike with normally open and normally closed switches, so they only provide uh, 2 points. So this point here and this point here. So uh, for normally open, so once triggered, so this will have or this will create uh, a connection between this point and this point. So for changeover contact switch, okay, so it has actually three points. So a common point, so this would be the common point, and then you have there a provision for normally closed, and then a provision for normally open point also. Okay, so take note again, switches uh, can come either normally open or normally closed, and then it can be triggered either manually or automatically. Okay, so now uh, some of the commonly used switches in an electropneumatic system are given by. So the first type of commonly used switches in an electro-pneumatic system is given by the push button switches. So when you say push button switches, so they are momentary switches. So basically they are spring return switches. So meaning to say, once you press the push button, it changes contact. However, when you release the push button, it goes back to its original position. So there are two types of symbols that are being used or adapted. Uh, the first one is the what we so called Nema Standard. Nema stands for National Electrical Manufacturing Association. And then the second one is the IEC standard, so which is given or defined as International Electrotechnical Commission. So the first one, the NEMA standard, is actually the standard being adopted by the US. And then the latter one, I mean the second one, the IEC standard, is the standard being adopted by the most of the European countries. Okay, so with respect to the push button switches, the NEMA. Okay, so the NEMA configuration for push button switches is given by this symbol. Okay, so you have there the normally closed push button switches, and then you have there the normally open push button switches. Okay, so under NEMA standard, and then we have here in the right, okay, so the equivalent push button symbol under the IEC standard. So again, push button switches are momentary. So momentary means that, for example, when you have their uh, normally closed push button, when you press this normally close, so it becomes open. Then once you release, okay, so once you release the push button, it goes back to its original position, which is uh, a close position push button. Okay, so again, the symbol in the left is for NEMA, and then the symbol in the right is for IEC. Okay, so now another type of switch that is being used in electro-pneumatic system is the reed switch. So the concept and then the operation of a reed switch will be discussed later on. So the equivalent symbol, no, for a reed switch in NEMA classification is given by this one. So you have there normally open and normally closed. Under IEC, okay, so under IEC, so you have this equivalent symbol for a reed switch. So these are the pictures given are the most commonly available form of a reed switch in the market. Okay, so basically what we are talking right now are the equivalent symbols for the commonly used switches in electro-pneumatic control circuits. Okay, so another type of switch that is commonly used in electro-pneumatic control circuit is the limit switch. Okay, so now the equivalent NEMA uh, standard for the uh, equivalent drawing or equivalent diagram for a limit switch. So under NEMA classification is given by this symbol, and then the equivalent IEC symbol for a limit switch is given by this symbol also. So the function and then the operation of a limit switch will also be discussed later on. Okay, so again, what we are talking right now is the equivalent symbol for a given type of switch. So another one is the timer switch. Okay, so the timer switch is given by the following symbols now for normally closed under NEMA standard. Okay, so this symbol, and then under IEC, so we have also this symbol in the right side. Okay, so this would be for NEMA, and then this would be for IEC standard. Okay, so as mentioned a while ago, switches can either be operated manually or automatically. So when you have there manually, so there must be mechanical means wherein once a switch is triggered, so it will change position. For automatically operated switches, so most of the automatically operated switches are operating under what we call electrical signal. And then uh, the electrical device, okay, so or an electrically operated switch basically is termed as a relay. So unlike with uh, a switch, okay, so or unlike with a mechanically operated switch, a relay is electrically operated. So that means a relay, the function of a relay is to or uh, create or make a contact, or it can either break a contact. So basically, the relay is still a switch. However, it will only change contact, it will only change position. Okay, so for its contact, only if it is given with electrical signal. Okay, so now these are the common or the commonly available relays in the market. Okay, so the parts of a relay, okay, so are given by, so the first one is the coil, and then the second one is the auxiliary contacts. Okay, so the coil, okay, so for a relay, so for a relay to operate, the coil must be given with uh, its rated voltage. Okay, so for example, you have there 24 volts relay, then the 24 volts relay must be given with 24 volts. So if more than 24 volts is given, then the relay will be damaged and will be burned. Okay, so however, if when a relay is provided with less than the rated voltage, okay, then the relay will not function properly also. Okay, so how come a relay becomes a switch. Okay, so now the relay consists of actually what we so called auxiliary contacts. Okay, so these auxiliary contacts are normally open and normally closed contacts. Okay, so now unlike with a push button, okay, so unlike with a push button that uh, when the device is being pressed, okay, so for example, the push button is being pressed, so a normally closed push button becomes open, okay, so and then when it is released, it goes back to its closed position. A relay on the other hand, okay, so a relay on the other hand uh, will only change contact from closed to open or open to closed, okay, or vice versa. It will only change contact only if the coil is being supplied with its rated voltage. Thereby, we define a relay as an electrically operated switch. Okay, so it is still a switch because it can create or break contact. Okay, so the symbol for the coil of the relay is or are given by the following. So on the left side, so you have there the Nema uh, equivalent symbol, and then on the right side, so you have there the IEC equivalent symbol. So the auxiliary contacts of a relay are given by so normally open and normally closed. So on the left side, so we have there the NEMA equivalent uh, symbol, and then on the right side, so you have there the IEC equivalent symbol for the auxiliary contacts of a relay. So let's try to take a look on how does a relay works. Okay, so now focus your attention on this side. Okay, so you have initially, uh, for example, you select the common, okay, so this common point and then this point also. So if you try to look at from this point, so going to this point, and then this point going to this point, so it is actually normally open. So why it is normally open? Because we do not have the connection from common to normally open terminal. Okay, so this is actually open. And if you try to look at from common to normally closed, so it is termed normally closed because we have a connection. Okay, so try to follow the cursor. Okay, so it is actually connected, okay, from common to the normally closed. So hence it is called normally closed. So how do a relay work? Okay, so as mentioned, so in order for the relay to work as a switch, it must be supplied with a rated voltage. So the voltage will be supplied here in the coil terminals. Okay, so once it is supplied with the voltage, so current will flow. No, so electrical current will flow in the wires in the coil. And then if you try to recall in your physics before, the concept of electromagnetism, when there is actually current that will flow in a coil, okay, so in a conductor that is being wound, it will create magnetism. Okay, meaning to say, once voltage is being supplied, in the coil. So current will flow in this coil or in this wire, and then magnetism will be created. So once you have there the magnetism, it will attract. Okay, so it will attract this movable armature. Okay, so this one. So once it is, or it will be attracted. Okay, so once it will be attracted, so this point here will be moved. Okay, so or will be attached to this point, and then since this is actually pivoted, meaning to say it can freely move without being detached. Okay, so this point. So once this part here moves to this point, so this part of the armature will move upward. Okay, so and then if it moves upward, it then hits the common terminal. Okay, so once the common terminal will be hit by the armature, the normally closed position will be open, and then the open position will be closed. Okay, so why does the normally closed contact becomes open? So because the movable contact of the common terminal will now be detached from this what we call terminal, and then it will be now attached to the open terminal. So the open terminal, okay, so together with the common will now form a close contact, and then the initial closed contact between the normally closed and common will now be uh, open. So that is why we term the relay as an electrically operated switch. So once the relay will be cut off from the supply, or once the relay will be de-energized, or basically the supply is being turned off, so this movable part here will go back to its original position by means of a spring, and then uh, this movable point also will go back to its original position. So meaning to say the normally closed contact which was opened after energizing the coil will now become closed again, and then the normally open which was being closed after energizing the coil will now become open again. Now the next part would be the part of the electro-pneumatic system that provides the mechanical setup, so which is actually the pneumatic cylinders. So under electro-pneumatics, we'll be talking about two uh, types of electro-pneumatic cylinders. So the first one is the single acting cylinders, no, or SAC. Okay, so single acting cylinder, so use the pressure imparted by compressed air, so to create in one direction, and a spring to return to the initial position. So it can be visualized as this one. Okay, so the single acting cylinder so actually uses air. So in order for the piston rod, okay, so in order for the piston rod to move forward or to be extended, however, for the piston rod to return to its initial position, so it uses the force of the spring. Okay, so for the piston rod to return to its initial position. So this would be the typical what we call actual appearance of a single acting cylinder. So there is only one service port. Okay, so in this port here, uh, this will be connected to the corresponding directional valve. So wherein air will flow through this port. Okay, so the pressure coming from the air will push the piston rod to be in extended position. Okay, so take note, the pressure of the air must be greater than the pressure created by the spring. Okay, so in order for the rod to extend. Okay, so now for the rod or for the piston rod to return to its initial position, then the air in this part or in this chamber must be removed. Okay, so it will be removed through the what we so called exhaust point, and then once the air is being removed, simultaneously the spring will push the piston rod backward, moving it to its initial position. Okay, so to further visualize, so this would be the operation of a single acting cylinder. Okay, so the sky blue color, okay, so is actually the air. Okay, so coming from the compressor, for example. Okay, so the air is being used to push the piston rod. Okay, so now if we cut off, no, so if we cut off the flow of air, so the spring will be able to push, okay, so the piston rod backwards. Okay, so now in order for the single acting cylinder, okay, so in order for the single acting cylinder to maintain in extended position. Okay, so like this one, no? So if you want the single acting cylinder to remain in the extended position, then the flow of air, okay, so take note, the flow of air from the compressed uh, source to the cylinder must be maintained. Okay, so if you try to cut off the flow of air, then the spring will tend to push the remaining air in this part of the cylinder going to the exhaust. Okay, so try to observe what happens to the air. Okay, so what happens to the air when the cylinder will retract. Okay, so the air here will be exhausted to this point. That means it will be released to this point by means of the retraction of the piston rod uh, with its spring mechanism. Okay, so again, take note that in order for the cylinder to maintain in its extended position, then the air must be continuously allowed to flow into the cylinder. So once it is being cut off, okay, so once it is being cut off, then the cylinder will automatically retract. Okay, so another type of pneumatic cylinder is the double acting cylinder. Okay, so now The same way with the single acting cylinder, the double acting cylinder uses actually air. So for the cylinder to extend, however, the difference between the duct and sac is that uh, the way for the single acting cylinder to retract is by means of the spring. For the double acting cylinder, so the only way to, or the way for a double acting cylinder to retract is through the use of air also. So meaning to say, in a double acting cylinder, there are actually 2 points. Okay, so uh, if you try to look at in this uh, picture, so when air is allowed to flow in this direction, okay, so it pushes actually the piston rod. Okay, so it pushes the piston rod, thereby the double acting cylinder will extend. Okay, so now, so in order for the cylinder to retract, so the double acting cylinder does not have a presence of spring. So what will happen is that uh, the air must be allowed to flow into the other direction. Okay, so in this direction, so this will push the uh, piston rod to its reverse direction, thereby allowing the double acting cylinder to be in its retracted position. So unlike with the single acting cylinder that it uses spring, the double acting cylinder uses both air pressure to extend its position or to retract its position. This would be the available double acting cylinder that can be found in the market. So you notice that there are actually 2 ports. So one port so will be used momentarily. This port will be used momentarily as an inlet. Okay, so this will serve as a point of entrance for the air uh, for the cylinder to extend, and the second port here will be used also momentarily. Okay, so as an entrance uh, of the air for the cylinder to return to its uh, initial position. So both of the ports are actually used as entrance and exit of the air. So when you want the cylinder to extend, this port here will be the entrance of the air, and then this port here will be the exhaust. So try to look at in this position. So the remaining air here will be exhausted or will be released at this port, so thereby allowing the cylinder to move forward. And when the cylinder is retracted, so this port here will be used as the air entrance, and then this port here will be used as an exhaust point or not as an exhaust port. Okay, so uh, another very important part in an electropneumatic circuit is the directional valve. So take note, uh, the cylinders or the pneumatic cylinders cannot be directly controlled by the electrical circuit. That means that the cylinders does not have any part that can be supplied with electricity. So only the air can make the cylinder extend or retract. So in order to command the cylinder when to extend or when to retract, it must be coupled with, okay, so it must be coupled with the what we so called as directional valve. Okay, so now to further, before we'll go to the directional valves, so we'll try to visualize the operation of double acting cylinders. So you notice, okay, in this uh, diagram, okay, so the light blue color represents actually the direction of the air. So when the cylinder is in extended position, it is actually being pushed by air, and then it is actually pushed again backwards by air for the cylinder to move to its uh, initial retracted position. So as mentioned, uh, we cannot control the movement of the pneumatic cylinders by means of electricity. So the only way to allow the cylinder to move in extended or retracted position is through the use of the what we so called directional valves or solenoid valve. So meaning to say, the solenoid valves is the one that is being controlled by the electricity, which will then allow the passage of air going to the compressed air source to the pneumatic cylinders. So solenoid valves is an electromechanical device, so with a built-in coil. So this is where the voltage or current, electrical current is given. Okay, so it consists of a coil and a pneumatic or hydraulic directional control valve. Okay, so just like with the concept of a relay, as mentioned from the previous slides, so a relay will only act. Okay, so it will only act as a switch. So when the coil is being supplied by its rated voltage, so in the same way, a solenoid valve so will uh, only allow the passage of air when the coil or when its coil is being supplied with the rated voltage. Okay, so these are the some of the uh, solenoid valves that can be uh, bought in the market. Okay, so the solenoid valves consist of, so in the outer part you can see the solenoid coils. Okay, so this is where the voltage is being supplied. So if you try to look at, so in this um, figure, in this picture, so this is the solenoid coil, and in the second part, so this is also the solenoid coil. So actually it comes with two two wire. Okay, so wherein it will be connected, or the two wires coming from the solenoid coils will be connected into an electrical circuit. Okay, so it comes up with the solenoid coils, no? So this is where we supply the voltage. So the service port, or the outlet. So these are the ports, no? So that is, or that are being connected to the pneumatic cylinder. So depending on the type of solenoid valve, so the number of service port will also vary. So we will discuss uh, more of that in the upcoming slides. And then the inlet port, so this is where the source of air will be connected. So basically, the source of air will be connected, and then in the service port, so it is where the pneumatic cylinder is being connected. So if you try to look at the air coming from the compressed air source will not flow directly to the pneumatic cylinder, not unless the solenoid coil is being energized. Okay, so the inner components of a solenoid valve, okay, so that means the inside, no, components of a solenoid valve are given by, so you have there the solenoid coil, okay, so the black ones, so this represents actually the wire, no, so that is being wound. So when we say coil, so we are referring to wire or wires, no, so that are being wound. And then you have there the spring, and then you have there the plunger. Okay, so all of which can be found inside the solenoid valve. So how does the solenoid valve work? Okay, so if you try to look at, okay, so if you try to look at here, so first the solenoid valve must be supplied with the rated voltage. So P for positive, N for negative. Okay, supply. So through a push button switch. Okay, so if you try to look at when the circuit is completed, that means when the push button switch is being pressed or closed, the solenoid valve or the coil is energized. Okay, so once the coil is energized, it creates magnetism. Okay, so this creates magnetism, and then once it creates magnetism, it actually attracts the uh, metal plunger. Okay, so the plunger is made of magnetic material wherein when there is a presence of magnet in the solenoid coil, this plunger will be attracted. Okay, so attracted means it will being pushed in this direction. Okay, so once the plunger is being pushed upward, so the opening from the inlet to the service port will now be open. So as you can see, the yellow color represents the flow of air. So initially, okay, so if you try to look at, if the plunger is in downward position, that means the supply is not yet given to the coil. So the plunger is in downward position, it actually blocks the flow of air. Okay, so but when the solenoid is being supplied with the voltage, so the plunger will be moved upward, creating an opening from the inlet going to the service port. Okay, so that is how the solenoid valve works. So again, for a solenoid valve to work, okay, so the coil must be supplied with the rated voltage. Once it is supplied with the rated voltage, the plunger, you know. So the plunger will be attracted by means of magnetism, okay, so thereby allowing the passage of air from inlet to the service port. Okay, so how to stop the passage of air? Okay, so in order for the passage of air to be blocked, so the supply, okay, so the supply must be cut off. So once it is cut off, then the spring, okay, so the spring here will push the plunger. Okay, so it will push the plunger downwards. So once it goes back to its initial position, then the passage of air is now blocked. Okay, so again, a solenoid valve works only if the coil of its solenoid will be supplied with a rated voltage. So once the supply is cut off, so the plunger of the solenoid valve will block the passage of air. Okay, so in simple terms, we would say that in order for the solenoid valve to allow the passage of air, it must be supplied with the rated voltage. Okay, so and then to block the passage of air, then the supply must be needed to be cut off, or basically the supply must be turned off. Okay, so we will now then try to explore how to use the fluid sim software to build and simulate electro-pneumatic system. So we'll be using the uh, single acting cylinder together with the corresponding solenoid valve. Okay, so for single acting cylinder, so the corresponding solenoid valve or directional valve to be used is the what we so called 3/2-way solenoid valve. Basically, it will be read as 3 2-way valve. Okay, so now 3 2-way valves are the solenoid valves, okay, that are being used to control the direction of a single acting cylinder. Okay, so when you say single acting cylinder, it must be paired with 3 2-way valve. Okay, now so this is an example of a 3 2-way valve, and on the right side, so this is the schematic symbol for the given 3 2-way valve. Okay, so as you can see, okay, so in this figure, so the compressed air, okay, so is connected to the 3 2-way valve. Okay, so and then the cylinder also is connected to the 3 2-way valve. So the blue color line represents the path of the air. So initially, the air cannot flow directly to the uh, single acting cylinder. Okay, so now in order for the air to flow to the single acting cylinder, then the solenoid coil of the 3 2-way valve must be energized with its rated voltage. So once it is energized, as you can see, the plunger moves, no? So the plunger moves uh, the same way as with this illustration. Okay, So when it is being supplied, so the plunger moves, so it allows the passage of air. Okay, so you can see the blue line. Okay, the blue colored line represents the passage of air. So uh, the cylinder now is in extended position because the air is allowed to flow from the compressed source to the uh, pneumatic cylinder, or basically single acting cylinder. Okay, so three two-way valves are named, or is named three two-way valve because of the following configuration. Okay, so 3 stands for the number of ports, and then 2 represents the number of position, okay, so of the cylinder. So the position is either in extended or retracted position. Okay, so 3 stands for the number of ports, no? So if you try to look at, so there are numberings present, 1, 2, and 3. So 1, uh, okay, so 1 represents the inlet. Okay, so this is where the compressor or the compressed air is being connected. 2 represents the connection to the cylinder, and 3 so represents actually the exhaust port. Okay, so what is the purpose of the exhaust port? So the exhaust is given when the cylinder or the single acting cylinder will be brought to its initial position. So recall that in a single acting cylinder, okay, so air is being used to uh, push the piston rod to its extended position. When the cylinder is returned to its uh, original position, which is the retracted position, then the air in this uh, part of the cylinder must be removed. Okay, so for the spring to be able to push backwards the piston rod, and then this air that is contained in this volume will be exhausted. Okay, so try to look at in this part. So all air must be exhausted to point 3 for the cylinder to be retracted to its original position. Okay, so you have there three two-way valves. 3 stands for the number of ports. So the number of ports are, or the ports are, the inlet port, the service port, okay, and then the exhaust port. So there are actually three. 2 stands for the number of position. So either fully extended or fully retracted position. Okay, and then uh, so we'll be using the what we so called ladder diagram setup to create electrical uh, circuit controller for the pneumatic system. So it is termed ladder because it looks like actually a ladder. Okay, so the ladder diagram will be used to construct the what we so called electrical control circuit of an electro-pneumatic system. So there are two types of ladder diagram. So as you can see, so a ladder diagram which goes from upward to downward, and then we also have the second type of ladder diagram wherein it goes from left to right direction. That means the first one is vertical direction, the second one is uh, horizontal direction. Okay, so this ladder diagram uses Nema. Okay, so Nema equivalent symbols, whereas this type of ladder diagram uses the IEC equivalent symbols. So in a ladder diagram, the flow of the sequence in an electrical circuit flows from the topmost to the next part. We call this one rung. Okay, so this would be the first rung, second rung, third rung, fourth rung, and so on. So normally in a ladder diagram, the sequence will go from the first rung, okay, or the control will be given in the first rung. So going to the next rung, then go to the third rung, and so on. Okay, so later on, we'll try to construct simple ladder diagrams, and then out from simple ladder diagrams, we'll then use or will then try to construct a more complicated ladder diagrams for electro pneumatic system. Okay, so now we'll try to explore on how to use the fluid sim software. Okay, so now assuming that you have already downloaded the software, okay, so assuming that you have already unzipped the software, so the first thing to do is to open this folder fl underscore sim. Okay, so you open the folder, then go to bin. Okay, so go to bin, and then you double click the application. Okay, so this application, you double click this one. Okay, and then you will be prompted with the component library. Okay, so first tab, so you will have the supply elements. Okay, so you have there, you will find here the source of air. No? So the most important part here is the compressed air supply. So take note that the fluid sim can also be used with other applications, not just the electro-pneumatic application. So meaning to say, so there will be some components in the library that may not be of use with the uh, electro-pneumatic application. So in the next tab, so you will have the actuators, no? So you will have the cylinders. So we'll be using the single acting cylinder and double acting cylinders. Okay, then in the tab below, so you will have there the solenoid operated. Okay, so this will be the solenoid operated uh, valve. So you will have here the uh, types of solenoid valves. Okay, and then okay, so you will have the other elements. Okay, so later on we'll try to use some of them. And then, okay, so this tab may not be useful to this uh, electro-pneumatics system. Okay, so and then you have there the power supply. Okay, so and then the relays, no, so for IEC format, switches, no, for IEC format also. So relay contacts, okay, so for IEC format, and then you have there in this tab ladder symbols. Okay, so to be used for the construction of electro-pneumatic system using the Nema uh, equivalent symbols. So for Nema, if you're using Nema, then you use all the symbols under this tab. Okay, so ladder symbols, and then you have there some of the capabilities of the software. So again, we cannot use all of the components in the library, so we'll just pick components that might be useful with the designed electro-pneumatic system. So after opening the software, so we need to click new. Okay, so you may choose file then new. Okay, or just click this symbol below file, and then you will be given with the working what we call this one, working part wherein you can create and simulate electro-pneumatic system. Okay, so now the first discussion will be on the relays. Okay, so for you to be able to uh, use and apply properly the relays. Okay, so the purpose of the relays, no? Okay, so we'll use the Nema. Okay, so Nema Standard or Nema equivalent symbols. Okay, so to illustrate the function of a relay. Okay, so to create a ladder circuit, first we need or you need to have the supply voltage. So the supply voltage is given by the uh, source 24 and 0. Okay, so you need to click this one 24, just click and then drag it in the working uh, part, no, so of the fluid sim working area. Okay, and then you have the 0. Okay, so you place it uh, away, no, so from the 24 or the positive terminal. Okay, so now one thing that must be avoided during the design process is the direct connection of the positive terminal to the negative terminal, because it will create a short circuit. Now, so for example, if you try to connect directly to the negative terminal, and then you try to simulate, no, so using this button, okay, or you can press F9. Okay, so if you try to simulate, So automatically the software will prompt you that there is what we so called a short circuit. No? So uh, since we're doing simulation, you will be prompted, but during actual, so there may be components that might be damaged when there is this what we so called short circuit, no? So uh, that may happen, no? So in the actual connection of wires. Okay, so we need to remove this one. Okay, so just click and then delete. Okay, so now let's try to look at the operation of a relay. Okay, so remember, a relay consists of a coil and its auxiliary contacts. Okay, so if you try to click relay, just click this one and then drag it in the working area. Okay, so this should be the coil of the relay. Now, in order for the relay to act as a switch, so this must be supplied with the rated voltage. Okay, so assuming that we name the relay K1, okay, so you double click and then type K1, okay, so this will be the name of the relay K1. So in order for this relay to function, then this must be connected to the supply. Okay, so one to the positive terminal and one to the negative terminal. Okay, so in order to connect, you'll just need to click in one of its terminal, click, and then uh, drag it to the point wherein you want to connect that particular terminal and then release. So it will automatically connect. So to simulate, so if you try to look at, okay, so to simulate, so the red lines here represents the flow of electrical current. So that means the signal is flowing from the positive terminal going to the negative terminal passing the relay coil. Okay, so we'll stop the simulation and then we'll try to add normally closed and normally open contact. Okay, so for normally open, we have make switch. So just click this one. Okay, so click, place it in the working area. Normally close. So this would be brake switch. Okay, so place it in the working area. Okay, so we'll try to zoom. So this should be the symbol, no? So for the auxiliary contacts. Now, in fluid sim, it is a must that the auxiliary contacts must be named in accordance with its coil. So for example, so this relay contacts, auxiliary contacts, is intended for K1, then this must be named K1 also. So you double click, okay, so double click this one, and then you leave it as limit switch, no? So just leave it at this point, and then you label this one K1. Okay, so you may use small letter, it will automatically convert to capital letters. So you notice that the symbol changes, okay, so to this one, no? So the NEMA equivalent symbol for the normally open contact or normally open auxiliary contact. And then this one will be change, double click, and then label this one as K1. that would be the symbol changes to this one, the NEMA equivalent uh, symbol for the auxiliary contact K1. Okay, so if we try to simulate, just try to take a look. So if you try to simulate, okay, so now when the coil is energized, the normally open, okay, so the normally open contact becomes closed and the normally closed contact becomes open. Okay, so that's how relay works, no? So in order, okay, so let me stop the simulation and try to look. This is actually open and this is actually normally closed. But if you mistakenly name the contact as, for example, you name this one K2, so you notice that the symbol remains the same because this is not, or this will not be treated as normally open contact of relay K1. Okay, so why? Because its name is K2. And then if you try to simulate, so nothing happens to, okay, so nothing happens to K2 because it is not part of the relay K1. Okay, so we need to change this one to K1. And then once we uh, on the circuit, basically simulate, so the open becomes closed, the closed becomes open. Okay, so now in practical applications, okay, so in practical applications, uh, relays, okay, so relays are not connected directly to the source. That means when the source is turned on, so it is a must that the relay coils will not be energized directly. Okay, so it will wait for the operator to be energized. No? So, meaning to say, uh, there must be the presence of switches. Okay, so now wherein if we try to enable the switch, then that would be the time the relay, okay, the relay, the lamps, or uh, any electrical uh, elements will be energized, no? So what we do is we try to insert, no? Okay, so we try to insert uh, a switch. Okay, so wherein if we try to press the switch, then that would be the time the relay will be energized, no? So just click and then delete. Okay, so this time we try to use the normally open push button. Okay, so push button, make, click, and then drag it to the working area. Okay, so assuming that you have the uh, push button in this location and then you try to connect. Okay, so like this one. Okay, so uh, if you run the circuit, so it is still okay. No, so but then for uh, clarity, so in the circuit, so it would be better if we try to align all the elements properly. So you can just click this one and then drag it downwards. So the same way with this one, you can drag it downwards. Okay, so such that all the elements are now being uh, interconnected. Okay, so uh, we can name this one double click as start push button, or shall we say uh, start. Okay, that means um, in order for the relay to be energized, then we must start or press the start push button. So as you can see, if we try to simulate, the relay is not yet energized because the circuit is open. Okay, so it is actually an open circuit. So if we try to press, okay, so if we try to press, just click this push button. Okay, so when you click the push button, so that enables, okay, so this one, okay, so that enables the relay to function as a switch also. So where is the switch function of the relay? So try to observe what happens to the uh, what we call this one, the auxiliary contacts of the relay. Okay, so you press this one. So this is open and this is closed. Okay, so when you press this one, so the relay, okay, so the relay coil is energized. So the open contact becomes closed, and then the closed contact becomes open. And remember the definition of a switch. Okay, so it is an electrical element, okay, so that make or break contact in an electrical circuit. Okay, and then you notice that the problem with uh, the problem with the push button is that it's momentary. So when you say momentary, okay, so you press the relay is energized. However, when we release the relay, de-energizes also. Okay, so now what needs to be done usually is when the operator press the start push button, so the relay coil or the relay must be uh, or must continue to be energized even if the relay is being um, or even if the normally open push button is being uh, released. So meaning to say, if we try to release the normally open push button, the relay must still be energized. Okay, so to what we call this one, to allow the relay to be energized, then there must be done something. Okay, so to continue the operation of the relay, so the open contact provided by the push button must be sealed. Okay, so what do we mean by must be sealed is that uh, there must be something that when the push button becomes open, there must be something that makes the 2 points, this one and this one, to be connected in order for the relay to be energized. always. Okay, so now we call the process as sealing or latching. Okay, sealing or latch. No, so now that is provided by a normally open auxiliary contact of a relay. The purpose of the sealing contact or latching contact is to maintain the operation of the relay. So what we do is we put the sealing contact or the normally open contact of the relay so in parallel with the normally open push button. Okay, so uh, we try to connect so this end, okay, so to this point or anywhere. Okay, so you put it there. Okay, so you may delete. Okay, so okay, so you may put it here. Okay, so the red dot, now the black dot means this point and this point are connected, and then you may put it, connect it here. Okay, and then we try to run the circuit, or we try to on the circuit. Okay, so this time if we try to click start, so the relay is energized, but if we try to release the push button, so the relay continues to uh, be energized because of the sealing contact. Instead of the current will flow in this direction, it is actually bypassed in this direction to the relay. So this is the purpose of the sealing contact. So it is used to maintain. Okay, so it is used to maintain the uh, operation of relay, for example. Okay, so again, it is normally open contact. So to be connected in parallel with the um, normally open push button. Okay, so and then we may add in the circuit, okay, so an indicator, so indicator light. So normally in actual operation, so in order for the operator, okay, so in order for the operator to know that the relay is functioning or the relay is energized, so an indicator lamp is being used. Okay, so in this case, so remember in your um, electrical circuit, uh, the parallel connection of two elements for them to have the same voltage. Okay, so we need to connect the two um, elements in parallel. Okay, so we connect it in that point, and then we also need to connect this one in this point, no? So they are now connected in parallel, so you can choose as to what color you want. For example, green. Okay, so that means when we try to uh, start this one, so as an operator, you will know that the circuit is energized because of the indicating or indicator lamp. Okay, so in this case, uh, the only way to de-energize or to turn off the circuit is to turn off the supply. Okay, so there is no way we can turn the, or there is no way we can turn off the relay. So the only way to turn off the relay is to turn off the supply. Okay, so but then in practical applications, so you cannot just turn on and off the supply. Okay, so just to turn on and off the um, relay or whatever electrical element. So to turn off, we need something that will break the circuit. Okay, and remember, switches, no? So normally closed switches can break the circuit. Okay, so in this case, we need to have, or we need to add. Okay, so try to move it in this side. Okay, so we need to add. Okay, so we try to delete it. Okay, so this connection, try to move it here. Okay, try to move it here. Okay, so we need to add a normally closed push button. Okay, so we drag it. Okay, so brake push button normally close. So take note, uh, the concept of series circuit, no? So in your electrical circuit, so the normally closed push button must be connected in series with all the elements connected. Okay, so in series circuit, when one element or the series element is being damaged, okay, so everything in the series circuit will be affected. So meaning to say, if we try to put the normally closed push button in series, so if we try to break the flow of current, then everything in the circuit will be turned off also. Okay, so we try to connect, no? So the normally closed. Okay, so in series with all the circuit elements. Okay, so these are all the circuit elements that we have. Okay, so uh, the connection or all the circuit elements are connected to or in series with the normally closed push button. Okay, so we can rename the push button as stop. Okay, so if we try to simulate, so we can on the circuit. Okay, so even if we try to release, so the circuit maintains its energized condition because of the latching contact. So this time we can turn off the coil even without turning off the supply. So how to turn on, how to turn off. So just click the stop push button. So if we try to break the circuit, so everything is now turned off. So even if the push button, stop push button is uh, bring back to its original position, which is okay. So the only way to start the circuit is to start again. Okay, so it can be started again, and then it can be stopped. So let's look at then next is we try to add another uh, rung in the ladder circuitry. So for example, we want to add another set of relay. Okay, so wherein we can uh, turn it on independently from the previous relay. So we can set up another rung in the ladder circuitry. Okay, so we can add relay. So this one. So before you can add, so you stop the simulation first. So add another coil, for example K2. So this will be renamed double click K2, and then okay, so K2, and then you want another push button to control K2. So this should be start 2. Okay, so and then okay, so in order for this relay to be energized, so it must be connected to the supply. Okay, so this must be connected to the negative terminal, and supposedly it must be connected to the positive terminal, no? As mentioned, we need an electrical switch that will enable the uh, relay to be energized when the switch is pressed. Okay, so meaning to say we cannot just connect this one to the positive terminal. Okay, so just like this one, so because once we turn on, so automatically the relay will be energized directly. So to prevent that one from happening, then uh, it must be connected in series with the normally open push button, just like this one. Okay, so and then the other end will be supposedly connected to the positive terminal. Okay, so now if we try to look at, we can start and then we can stop. Okay, so the first relay. For the second relay, we can start. Okay, so if we try to release, okay, so we try to release, it de-energizes. So therefore, we need to have, for example, we want the relay K2 to be energized even if we release the second push button, then we need to have a sealing contact or latching contact. Okay, so again, we need to stop the simulation first and then click, drag. Okay, so then this will be K2. Okay, so and then we connect it in parallel with the normally open push button. Okay, such that if we try to run, so if we try to start this one, the second relay, and then if we try to stop or de-energize, so nothing happens. Okay, so because the stop push button is connected in series with only the first relay. So the first option is to have a separate stop push button. Okay, so in order for the second relay to be de-energized, so we need to have another stop or another normally closed push button, or uh, we can place for example another stop push button 2, for example. Okay, and then connect it in series again and then connect it to the positive. Okay, so then if we try to simulate, we can start and then stop, we can start and then stop. Okay, so for simplicity in the process, normally in the practical setting, so for a single control circuit, there must be only one stop push button for emergency purposes. That means uh, the stop push button can de-energize the first relay. At the same time, it can also de-energize the second relay. So what we do is we connect the second circuit, okay, so this one, to the common terminal of the stop uh, button, making it or making the stop push button to be the common stop to all the circuit element. Okay, so we try to connect it there. Okay, so just like that. Okay, so such that, okay, so if we try to start the relay 1, you may stop, or if you may try to start relay 2, you can still use the stop button uh, used to stop the relay 1. Okay, so that means the stop push button is common to all of the relays. Okay, so start and then you can still start the second. Okay, so assuming we have another indicator lamp, so let's say yellow color. Okay, okay, so and then we try to start and then start the other. Okay, and then everything can be, okay, so everything can be de-energized using the stop push button. Now, what if we want independent operation from the two relays? Okay, so what we mean by independent operation is that what if we want the two relays, okay, so to operate independently. That means when one relay is operating, so the other relay must not be able to operate, okay, or vice versa. So for example, if relay 1 is operating, then by all means, even if we press this push button, relay 2 will not operate. So how do we do that? So we will find a way wherein if we try to operate relay 1, then relay 2 or K2 will be disabled. Okay, so this is where the concept of the normally closed contact of a relay will come in. Okay, so now the normally closed contact of a relay, okay, so can be used as an what we call this one, interlocking contact. So interlocking contact means it will lock the operation of the other relay component if a particular relay is in operation. For example, if K1 is in operation, then K2 must not or will not or cannot operate until K1 is in operation. Okay, so or when K2 is in operation, relay K1 must not be able to operate unless otherwise K2 is turned off. So to do that, okay, so uh, we need to find a way wherein we can do the interlocking of the two relays. Okay, so for example, if we try to insert here, uh, okay, so if we try to insert here relay K2, okay, so contact, normally closed contact K2, such that if we try to run K2, what happens now is that the K2 contact here, the normally closed K2 here, opened, no? So it opens, so thereby we cannot run K1 because the K2 contact here, or the K2 normally closed contact here, is open. Okay, so similarly, if we try to insert, okay, if we try to insert normally closed contact in between uh, this point, and then we name this one K1, okay, so and then we try to connect in series. Okay, so if we try to run K1, you notice K1 is normally closed. If we try to run K1, K1 here becomes open. So even if we try to run K2, nothing happens because K1 is open. Okay, so the only way is to stop the operation and then run K2. So similarly, we cannot run K1 because K2 here is open. Okay, so once it is open, so the electric current cannot flow from one or from this direction to the other direction. Okay, so we call the concept as interlocking. Okay, so it locks up the operation of an existing relay such that the other relay cannot be put into operation. Okay, so that is the concept of relay. Okay, so on how we use the relay in relation to the what we so called as um, ladder circuit. Okay, so we now then try to apply the uh, concept learned in forming electro-pneumatic uh, circuit. Okay, so we try to erase this one. So for electro-pneumatic, we try to control the uh, single acting cylinder. So we now try to control the single acting cylinder using electrical circuit. Okay, so the first one is to go to the first thing to do is to go to the actuators, select single acting cylinder, and then click and drag it to the working area. Okay, so you have the single acting cylinder, and then next is to find the solenoid operated valve. And then take note, for single acting cylinder, it is uh, the three two-way solenoid valve. Okay, so three two-way solenoid valve. And then next one is the um, source of compressed air. Okay, so click and then drag. coming from the supply elements. Okay, so again, if you can recall, uh, there are three ports. Okay, so port 1 is the inlet, click. Port 2 is the service port. Okay, you can click it there. Okay, so and then uh, this should be the pneumatic. Okay, so pneumatic circuit. So consisting of the cylinder, the directional valve, and then the source of compressed air. So next is we try to do the uh, operation of the single acting cylinder. Okay, so first we need to go to the ladder. Okay, so still we'll be using Nema. Okay, so click positive. Okay, then click negative. Okay, so if you remember, so the only way to control the single acting cylinder is to control the uh, directional valve or the three-way valve. Okay, and then if you try to recall in the PowerPoint presentation, solenoid valve will only work if its solenoid coil is being energized. Okay, so where is the solenoid coil? So the solenoid coil for the three-way valve is actually here. So this solenoid coil here must be supplied with the rated voltage. Okay, so now the solenoid valve or solenoid coil, so this part here, okay, so must be supplied. Then we need to have the equivalent symbol or the equivalent circuit for the solenoid, and that's given by the valve solenoid, this one. So you click it, okay, and then place it here. Okay, now assuming that we connect it directly to the source. Okay, so let's say we name this one Y1. Okay, so if we try to simulate, Y1 is now energized, yet the cylinder is not yet uh, moved to its extended position. So how come? So the answer is we haven't yet named the solenoid coil of the solenoid valve. Okay, so to name this one, okay, so you double click this part here. Okay, so you double click this one and then name it Y1. Okay, so meaning to say, this solenoid coil here is the one that is being supplied with the voltage here. Okay, so if we try to look at, so when we try to simulate, that means we try to turn on the supply. So directly, the solenoid valve or the solenoid coil Y1 is energized, thereby allowing the passage of air to flow from the compressor to the cylinder. Okay, so now ideally, again, uh, you cannot just turn on and off the power supply. Okay, so in order for an electrical element to be turned on and off, so there must be a mechanism wherein once triggered, it will turn on or it will turn off the given um, electrical circuit element, no? So in this case, we'll find a way wherein if we try to trigger that particular element, uh, it will enable this solenoid coil to be energized. And whose element is that? Okay, so the answer is the normally open push button. So such that, okay, so if we place, so take note, normally open will make contact, no? So that it will enable the solenoid coil to be connected to the power supply. Okay, so this must be connected in series, no? So with the solenoid coil. Okay, so we connect it there and then connect it to the positive. Okay, so again, it would be better if we align all the elements properly. So you can move it upward. Okay, so we can name it as start push button. Okay, or basically we can name it on. Okay, so if we try to uh, simulate, so when we press this one, so it will activate the solenoid coil. In return, it will allow the single acting cylinder to extend. Okay, so if we press on, so the single acting cylinder extends. However, when we release, so the solenoid valve de-energizes. So once it de-energizes, it blocks the air. Uh, okay, so it blocks the air coming from the compressor going to the cylinder. So thereby, the spring of the cylinder pushes the piston rod to its original retracted position. Okay, so now, what if we want the cylinder to remain in its extended position? Okay, so even if we try to release the push button, so unlike with the relay, a solenoid valve does not have, okay, it does not have uh, what we so called auxiliary contacts. No, so meaning to say that if we want to use the sealing contact to seal this normally open push button, then therefore we need to add a relay. So for example, we add a relay. So if we add a relay, so uh, you recall the concept of parallel circuit. Okay, so when the circuit is parallel, that means uh, when the parallel element is activated, since they are connected in parallel, uh, both of them will be activated at the same time. So meaning to say, we need to connect the relay in parallel with the solenoid valve. So in such a way that when the solenoid valve is activated, the relay is activated and its normally open auxiliary contact will also be activated, providing a sealing contact to the normally open push button. Okay, so assuming we name this one K1, okay, and then we uh, click make contact. Okay, so this will be K1. Okay, so and then if we try to connect this one in parallel, connect this one in parallel, okay, create this one and then create this one. Okay, so if we try to simulate, so if we try to turn on, so even if we release the push button, So the cylinder remains in its extended position because uh, we have now the sealing contact that seals the open part of the circuit. So again, uh, who will provide the sealing contact? It's not the solenoid valve because it does not have an auxiliary contact. Only relays will provide auxiliary contacts. Okay, so to return this one to its extended position, so the only way is to uh, turn off the circuit. Okay, so we cannot uh, retract the cylinder to its uh, initial position. So by any means in this control circuit, except if we turn off the circuit just like this one. So it goes back to its original position. So we can add instead a brake contact switch that will enable the solenoid valve to be turned off. Okay, so again, it will be connected in series. Okay, so such that once it is activated, everything, the current in the circuit will also be interrupted. So let's turn it stop. Okay, so if we try to simulate, so we can press. Okay, so if we release, so release, the cylinder remains in extended position. If we try to stop, the cylinder goes to its retracted position. How? So remember when the solenoid valve is de-energized, so the air will also be blocked. So thereby allowing the cylinder or the spring to push this piston rod to its backward direction. Okay, so start, start, and stop. Okay, so that's how uh, we incorporate the solenoid valve and the relay uh, to properly have a correct function of a single acting cylinder. In the next tutorial, in the next video, so we'll be discussing then the concept of the double acting cylinder together with its corresponding solenoid valve.